Hello, in the previous chapter, we have learned about joint distribution. In this chapter, we learn how to calculate the joint moment and conditional distribution. So this is an addition to previous chapter where we studied the joint behavior of two or more random variables. So this is the list of different sections and subsections of these chapters. So we'll first introduce joint moments. Then we will see that one of the joint moments, which is the expected value of a product of two random variables, can be interpreted as inner product of two random variables, and these will form a Hilbert space or a vector space of random variables. Then we will discuss covariance and other moments and see how we can estimate the mean of any function of two random variables using some of the joint moments. Then we will learn about the joint characteristic function. A characteristic function, one of them is just the Fourier transform of the joint distribution. So characteristic function characterizes the joint distribution of random variable because there is a one-to-one relationship between and we'll learn other kind of characteristic functions like moment generating function and so on. Following that, we will upgrade the conditional distribution of, let's say, one random variable given another one and so on. And using these, we will discuss a conditional expected value. So this is mainly this chapter. At the end of this chapter, we talk about two very important engineering applications of this course. One of them is in reliability theory. The other one is in estimation theory. So the estimation theory we will discuss about mean square estimation, nonlinear mean square estimation, and linear mean square estimation. So here the objective is not to learn the estimation theory, but just to introduce it enough so that if you need in future, you could learn this theory or reliability theory by yourself. So this is just an introduction, but it is enough for you to make yourself more familiar in future. On completing this chapter, students shall be able to determine and use various joint moments of multiple random variables. The joint characteristic function as the joint distribution. So alternatively, instead of joint distribution, you could use characteristic function or vice versa. The conditional distribution and moments of one random variable given the other one and so on. So there are cases that we know something and we want to make inference about the other one. For instance, in a communication system, we have the output of the channel and we want to interpret or evaluate the input of the channel. So we want to familiarize ourselves with different reliability parameters of a system, and then we'll talk about simple estimators.